Okay, so now we're going to discuss sequences. Now, a sequence is a list of numbers related to each other by a rule. Now, for example, we could have a sequence 5, 7, 9, 11, 13, and it could continue on in that fashion. Now, this sequence, it has a specific order. Each of the numbers that make up the sequence is called a term. So each of these individual numbers are called terms of the sequence. And of course that continues on forever. These are the terms of the sequence. And we're going to also have to look at some notation. The first term of the sequence is going to be called A1. A telling you the sequence is A, the subscript 1 telling you it's the first term in the sequence. A sub 2 is going to represent the second term of the sequence. A with a subscript of 3 represents the third term of the sequence. And if you have A with a subscript of n, that represents the nth term of the sequence. So this is the nth term of the sequence. So this is what we're going to be talking about. We're going to be talking about sequences, which are lists of numbers, and they're in an order, in a specific order, and we denote that order with the subscript. So the first term, for instance, of a sequence is A1, the second term of a sequence is A2, the third term is A3, A4, A5, all the way up to AN, and depending on what the last term of the sequence is, it might actually have a final number. All right, so that's what a sequence is. Now that we know what a sequence is, let's talk about a specific kind of sequence. All right. Okay, a sequence in which each term after the first differs from the preceding term by a constant amount. Is called an arithmetic sequence. So, when we have a sequence and it increments, each number after the first number increments by a constant amount, we call that an arithmetic sequence. All right, the amount by which each pair of successive terms differs is called a common difference. The common difference of an arithmetic sequence is the constant amount is the amount Okay, so when we're talking about an arithmetic sequence, each term after the first term is going to differ from this previous term by a constant amount. That constant amount is going to be called the common difference. So let's take a look at an example. The common difference is going to be denoted D. And remember, each pair of successive terms differs by that amount, D. And A1 is the first term of the sequence. All right, so let's take a look at an example. So we're going to write the first 5 terms of this arithmetic sequence. So we're going to write the first 5 terms, and let's see. We have that A1, which is the first term of the sequence. A1 is equal to negative 11, and D, the common difference, is equal to 5. So let's go ahead and write out the terms of this sequence. Well, A1, the first term of my sequence, A1 is negative 11. So I already have the first term. Now I'm just going to write out the other 4. Well, the second term has the difference between this term and the next term is that common difference of 5. So if I start with negative 11 and I know the next term has to be 5 units away, well, that's going to take me to negative 6. Negative 11 and negative 6 are 5 units from each other. The next term is going to be 5 units away from negative 6. So the next term is negative 1. So I have the first 3 terms so far. The next term is what I get when I add 5 to this. 5 units away is 4. And so far I have 4 terms. The last term is 5 units away from this one. So the last term is 9. And this sequence can continue on forever. But they only wanted me to list the first 5. 1, 2, 3, 4, 5 terms. So this was A1 that was given. This would be A2. This would be A3. This would be A4. And this would be A5. So I have all the first 5 terms of this sequence. All right. Let's try another one. Let's try this. A1 is equal to negative 3. And the common difference is negative 4. All right, well, let's list the first 5 terms of this sequence. The first term is negative 3. That was given. The next term is negative 4 units. That's the common difference. Negative 4 units away from this one. So that's negative 7. If you go in the negative direction, it's taking you to smaller numbers. And then the next number would be negative 11. The next one would be negative 15. So that's 1, 2, 3, 4. I just need one more term. Negative 19. So each one of these successive terms, each pair of successive terms is negative 4 units from each other. And this sequence could continue forever, but here's A1, A2, A3, A4, and A5. The first 5 terms of that arithmetic sequence. All right. Let's see what other kind of questions we can answer here. Okay. We can also be asked to determine an indicated term for an arithmetic sequence. All right, so let's go ahead and let's discuss the general nth term of an arithmetic sequence. So the general nth term of an arithmetic sequence. All right. So if an arithmetic sequence has first term called A1 and common difference, and the common difference we're going to call D, then the nth term is given by, so this is a formula for the nth term. The nth term is going to be equal to A1, which is the first term, plus, and it's going to be n, which is the term that we're looking at, the subscript for the term we're looking at, minus 1 multiplied by the common difference. So this is the formula for the nth term of an arithmetic sequence. So in order to find the nth term, all we have to know is the first term, a1, and the common difference, and we can find any term of an arithmetic sequence. So let's answer some questions that involve this nth term formula. Let's see. So we might be asked to determine the indicated term for the arithmetic sequence. All right, let's see what we can do. Let's take a look at this example. We're going to determine A7. We want to figure out what A7 is, and we're being told A1 is 12, and D, the common difference, is equal to -2. All right, based on this formula, if I want A7, the seventh term, if I want the seventh term, I take the first term, A1, which is 12, and I add to it N, but N is the number 7. We just established that. We're looking for the seventh term. So that's 7 minus 1, 7 minus 1 times D, the common difference, times D, which is -2. So I get, this is equal to 12 plus, and then 6 times -2, which is actually 12 minus 12. So it turned out that the seventh term is the number 0. So A7, the seventh term of this sequence, is the number 0. And we didn't have to go through all the terms between 1 and 7 to do that. We didn't have to continually add -2 to 12 7 times. All we had to do was plug into this formula. Let's try one more. All right, this is the formula we're going to use. All right, let's try this one. Determine A20. So we're looking for A20, the 20th term. That's what we want to find. The 20th term. And they say A1 is, let's say 13. And the common difference is, let's say 5. All right, so we're looking for the 20th term of a sequence that starts at 13 and adds 5 each time to get the next term. So this says that A20, the 20th term, is equal to A1, which we just said was 13, plus n minus 1, which is, well, n is once again 20, n is a subscript here, 20 minus 1, times D, the common difference, which is 5. So I get that this is 13 plus 20 minus 1 is 19 times 5. And let's see what we get there. 19 times 5, what's that? 45, 95. So we get this is 13 plus 95, or the 20th term of this sequence is the number, it seems to be 108. So 108 would be the 20th term of the arithmetic sequence that starts at 13 and adds 5 to get the next term each time. All right. Let's try one last problem that involves this theorem. So let's see. And let me write it up here again. A1, plus n minus 1 times the common difference. Let's try this problem now. Write an expression for the general nth term. So we're going to write an expression for the general nth term. So that's what we're being asked to do. We're being asked to write an expression for the general nth term. Well, in order to write an expression for the general nth term, I have to know A1 and I have to know D. I don't have to know N because that's the number of the term that I'm looking for. So I have to know A1 and I have to know D. So here's the example. This is the sequence that we're going to be looking at. We're going to look at the sequence -7, -2, 3, 8, and then it continues on in this fashion. So here's the sequence that we're talking about, this sequence right here. And what we want is we want to come up with an expression or a formula for calculating the general nth term. Well, in order to do that, I need to know A1. Well, that's easy enough. A1 is just the first term of the sequence, so I see here that A1 is equal to the number -7. So A1 is -7, that was easy enough. Then the other thing I have to know is I have to know the common difference. Well, the common difference is just the difference between successive terms. So if I take these two terms, well, the difference between -7 and -2 is 5. The difference between -2 and 3 is 5. The difference between 3 and 8 is 5. So the common difference, the difference between successive terms that's shared throughout the sequence is 5. So I get this for my nth term. My nth term, An, is equal to A1, which is -7, plus n minus 1, n minus 1. I don't know n, remember, until I can determine which term it is that I'm looking for. And I'm looking for the nth term, so I'm going to leave n as n, multiplied by 5. 5 is D, the common difference. So you get this expression, which you can simplify by distributing. You get -7 plus 5n minus 5. And then -7 and -5 gives you a -12. So An is actually -12 plus 5n. So that is a formula for the general nth term. The nth term is equal to -12 plus 5 times n. And if you plug in n equals 1, 2, 3, 4, 5, you'll get all these numbers. For instance, when n is equal to 1, you get 5 times 1 is 5, -12 plus 5 is 7. When n is equal to 2, you get 5 times 2 is 10, -12 plus 10 is -2, and so forth. So this is a formula that will give you the general nth term of this sequence. All right, last thing we're going to do with sequences. This was a formula for the general nth term. That was a formula for the general nth term. What I'm going to look at now is a formula for the nth partial sum. The nth partial sum. Well, the nth partial sum is the result of adding up n terms. So An just tells you what the term is. Sn, on the other hand, is equal to A1 plus A2 plus A3 plus, and then you add these up all the way up to An. So the nth partial sum is what you get when you add up all the terms up to the nth term. So we have a formula for An, but this is how you would calculate the nth partial sum. So let's give an example here. So we're going to determine the sum of the arithmetic sequence, and here we go. 2, 4, 6, 8. It continues on in this fashion. This is the sequence, and I want to calculate the sum. I want to calculate the sum of the first, let's say, 6 terms. So, if you have this sequence and you want to calculate the sum of the first 6 terms, well, the first term is 2, plus the second term is 4, plus the third term is 6, plus the fourth term is 8, plus the fifth term would be 10, plus, and the sixth term would be 12. So what we're doing is we're just adding up all of these terms. The sixth partial sum is the sum of the first 6 terms of the arithmetic sequence. So let's see, that's 6 plus 6 is 12, 12 plus 8 is 20, 30, 42. So the sum of the first 6 terms of this arithmetic sequence is 42. Now here's the thing, you might be saying to yourself, well, what if I wanted to calculate S50, the 50th partial sum? That would be difficult because I'd have to list all 50 terms and then add them up. Well, there's a formula for it actually. So let's talk about the formula. All right. So here's the sum of the first n terms of an arithmetic sequence. And this is more commonly referred to as the nth partial sum. The nth partial sum, Sn, is going to be equal to n multiplied by a1 plus an, all divided by 2. So you take the first term, add it to the nth term, you take the first term, add it to the nth term, and then divide by 2 and multiply the answer by n. So this is the sum of the first n terms of an arithmetic sequence. So let's try a harder problem. So I'm going to try to determine the sum of the first 50 terms of the arithmetic sequence. And here's the arithmetic sequence, 2, 4, 6, 8, that. So I'm going to try to determine the sum of the first 50 terms. Alright, so here's the formula. In the formula, I know that n is 50 because I'm calculating the sum of the first 50 terms. So I know n is 50. I know a1 is 2. So these are the things I know. I know n is equal to 50. I know a1 is equal to 2. And the only other thing I need to know is an. Oh, that's great. I know a formula for an. An is a50. And a50, the 50th term, is actually equal to a1, which is the first term, plus n minus 1, which is 50 minus 1, 49, multiplied by the common difference. And the common difference is 2 in this case. So I get that this is equal to 2 plus, and then that's 49 times 2. 49 times 2 is 98. So I get 2 plus 98, which is 100. So the 50th term of this sequence is the number 100. So now I can calculate the 50th partial sum. Well, here's the formula for the 50th partial sum. This is what I'm being asked to find. The 50th partial sum is equal to n, which is 50, multiplied by a1, which is 2, plus an, which we just found to be 100, divided by 2. Divided by 2. So let's calculate that. Let's see. That means that the sum of the first 50 terms of this sequence, if I had 2 plus 4 plus 6 plus 8 plus 10, all the way up to 100, I will get, let's see, that's going to be 102 times 50 divided by 2. So I get 2,550. So in this case, the sum of the first 50 terms of this sequence is 2,550. So that would be the answer to the question, the 50th partial sum.